Researchers at Michigan State University are using thermally treated biomass products as replacements for coal at the Simon Power Plant.
What's interesting and unique about this is that there were no modifications needed in the plant to burn this material. And so it's a direct drop-in replacement for coal.
Some power plants in Michigan are burning raw or green biomass mixed with coal. The problem is that many existing power plants cannot use green biomass.
They were designed to burn either coal or natural gas, and they cannot burn chunks of wood or bales of switchgrass. So what do we do with those plants? We need another piece of the puzzle. And so what we're trying here today is another one of those pieces of the puzzle, making something that acts and burns just like coal, so that plants that can only burn coal can use this material.
In the lab, biosystems and agricultural engineering students convert kilogram quantities of raw biomass wood chips into torrefied biomass.
We raise the temperature of biomass from room temperature to 200 to 400 degrees Celsius with the goal of partially charring that material. And so we add heat without oxygen and essentially char the material to a form that's more akin to coal.
The first material we produced was 275. We ground it to a 6.2 millimeter, and really, as you can see, produced a puck that was not as ideal. It's a little bit spongy, doesn't hold together as well. So we decided to lower the grind size and test that on the other products, which worked well. And once we discovered that 263 was the optimum temperature, we then took that further and explored heating the briquettes in addition to the grind. And once that was discovered to be very nice, we took another run and decided to grind the biomass even smaller to 2.2 millimeters. And you can see that the 2.2 millimeter heated briquette it's just a fine quality briquette. It's got a nice shiny surface which could indicate that it's starting to get properties where it won't allow water penetration. Definitely a point to explore is going to a smaller grind size and heating it and seeing what we can produce.
Getting out of the textbook and into the lab for hands-on learning is important.
It's really great to be in the lab. You learn a lot more. You know, you can look over the process so many times and understand what's happening, but to really grasp it and to see, you know, the before and after and what goes into the whole process, being in the lab really does that for you.
It's important to train the next generation's workforce, the next generation of engineers in a process like this, because they're more than likely going to be the engineers who run the small-scale torrefaction facilities located in the communities where the agricultural sources or silvicultural sources of biomass exist. They're also likely to be the engineers that run the power plants that burn this stuff.
We're going to need energy in the future, so you know, finding another energy source is very important. And also, just at Michigan State specifically, we have such a large research-based university. You know, we're doing small-scale work here, but our power plant is running, you know, this torrefied biomass in their power plant. So you can really see, you know, small scale go up to large scale, and it's really cool to see that all in one place. And you can get that here at Michigan State.